Okay, for our Unit I Theoretical Thursday, we're going to be talking about polarization and the polarization of waves, specifically light waves. So to start, polarization is a property of waves that can oscillate with more than one orientation. Electromagnetic waves, such as light, exhibit polarization, as do some other types of waves, such as gravitational waves. However, sound waves in a gas or liquid do not exhibit polarization, since the oscillation is always in the direction the wave travels. This is why electromagnetic waves work really well for polarization, since you have an electric field and a magnetic field that are both oscillating in different directions.
Bang! Etienne Louis Malus was a French officer, engineer, physicist, and mathematician. His discovery of polarization of light by reflection was published in 1809, and his theory of double refraction of light in crystals in 1810. Malus attempted to identify the relationship between the polarizing angle of reflection that he had discovered and the refractive index of the reflecting material. While he deduced the correct relation for water, he was unable to do so for the glasses due to the low quality of materials available to him.
As seen by the diagram, unpolarized light, after reflection at a shiny surface, in this case water, generally obtains a degree of polarization. This phenomenon was first observed in 1808 by mathematician Etienne Louis Malus, after whom Malus's law is named. Polarizing sunglasses exploit this effect to reduce glare and reflections by horizontal surfaces like water. The best example of where using polarized lenses would be the smartest is when fishing, when one can effectively cut the glare coming off the water to be able to see into the water and see where the fish are. Also, interestingly enough to note, if one looks at an LCD screen while using polarized lenses and one lays on their side or turns the lenses sideways, the image may become darkened, as some polarized light is given off by LCD screens. Displays are typically made with linear polarizers, and sunglasses are also made with linear polarizers. If you cross the axes of the linear polarizer of your sunglasses to the one in the display, you will see a dark display. There are some displays that are made with the axis of polarization at 45 degrees, so when viewed through linear polarizers, one does not see any degradation in brightness. If your application is one where you're typically using it outside, and if you're using a display that may have a linear polarizer, there are aftermarket integration companies that can add a quarter wave retarder to each side and make this display into one that responds to circular polarization, making it so that when you view it through your sunglasses at a certain angle, it doesn't darken. As we can see in this demonstration, when the sunglasses are turned sideways, it allows some of the previously cut out polarized rays to now show through.
That's neat.
So there you can see a little bit of purple light when it's turned halfway, and then there's a little bit of green coming through too. Purple. Green.
Now that we've discussed what polarization is, who discovered it, and some practical applications, now we can talk about the types of polarization. There are two types of polarization. Linear polarization, like the example of the sunglasses seeing into the water, or circular or elliptical polarization. The oscillation of the electric and magnetic fields may be in a single direction, which in that case it would be linear, or the field may rotate at the optical frequency, which would cause circular or elliptical polarization. In that case, the direction of the field's rotation, and thus the specified polarization, may be either clockwise or counterclockwise. This is referred to as the wave's handedness. In summation, the polarization of light is something we all experience every day and is crucial to physics. Understanding polarization is understanding light waves and that they travel transversely or parallel to each other.
Hey, pass.
Here you go, Danny G.
Hey guys, reaching the post.
TJ! I won!
Life.
Bang bang.
That's good.